All right, hello everybody, and thank you all one person for being here. So the point of this event is to talk about containers, what the value is, and how they relate to cloud tools. And so we're going to create our own small little Python server and upload it into the cloud so you can access it from anywhere, and talk about all the tools that are involved all the way through that can actually make that work. So just an introduction, my name is Eli, I'm one of the tech leads. I'm with Carlos, who's one of the other tech leads. This is our third to last event of the year. There's another event coming up, I think in 2 weeks, 2 or 3 weeks, and then we want to get April. Point of today, step one, figure out what are containers and why should you care about containers. Create the API server, Dockerize it, and then we're going to upload it to the cloud. We're going to use Google Cloud for this. Which hopefully uses the minimum amount of steps and can be the most useful for figuring out what's going on. All right, so the first thing to do here to kind of understand where the value of containers comes from is to go through a short little thought experiment. And so the thought experiment here is that if you are working, let's say you graduate UCF computer science, you make it through, your senior design project rocks, you get a perfect job at your dream company. And that company is almost guaranteed, if it's a software company, to have tools either for the employees in-house or the customers to connect to, depending on what those tools actually are. And in either case, some group is going to be using those tools basically every day. And so having reliability is really important. We want to make sure that those tools are always available. If there's any kind of maintenance, it needs to be as small as possible and as fast as possible. And we need to figure out a good way of actually creating this deployment. And so the question here really is, what are the challenges where if you were to go through this manually and have someone remote into a server on premise, assuming this company has their own servers and isn't also deploying to the cloud like we are, what are the challenges that they're going to face, both with the deployment process and also with maintenance? So some of these challenges are that you're using someone's time, which is always not good. If you can automate something, you probably should in this industry. The other problem you're going to have is, well, it works on my machine. So if I can create a local copy of the app that I'm creating and run it on my machine and it works, great, but it's not going to run on your machine full time. And so you need to be able to make sure that it also works onto the server where you're deploying it. And this can be really challenging, especially because most of these applications, when they get really, really big, have a very complex chain of dependencies. And all these dependencies have to be built together and have to agree together. One dependency uses a different version of another one than you have installed. You may have to upgrade it. And finding a good balance of dependency versions can be really challenging in some languages in particular, like Python, as I've experienced a lot in my senior design project this year. Additionally, if you have multiple applications on the same server, which is going to happen all the time, like you don't just create a server and have one instance of an application, that's hugely wasteful. And these applications use different versions of the same dependency. Well, now you have issues where you have to update the application that used the smaller version and upgrade it to the higher version. And that might cause something to break and then you need to fix it. And it's just an endless cycle. And maintenance and debugging in this case can be really challenging because you, again, have to have someone that remotes into the server to investigate where the issue is coming from, can compare it to your local environment to figure out what's different, and then actually come up with a solution. And ideally, we would have some way to be able to find all of our issues in advance and run it in a standard environment that we know will work on any device that we send it to or on any server. And this is really exactly the value of containers here. The container runs your application in an isolated little box. And in that box, it has everything that your application needs in order to function. Oftentimes, this might be a very small little Linux system that has all different directories. Sometimes it literally might just be the runtime that you need, like Node.js or a Python installation. And you can build your app into an image which says, take all of your application code and take all the things that it needs, put them all together, and then you can just send that anywhere you want. And if there is an executable on that server or on that other device, then it can execute it the exact same way as any other computer would. So if you know after you put it into an image and run that image in a container that it works, well, it's guaranteed to work on every other device as well, barring some sort of deployment issue, but that's a different problem and you can figure that out. So an image is where we build everything together and we can distribute images or we can save them to repositories so other people can use them. And it's just the arrangement of everything. And then we need to actually execute those in a container, which runs the thing, exposes all traffic, and can handle actually interacting with the application. In this case, there is no more case of it works on my machine, but it doesn't work here, because if it works on your machine, it will work everywhere else that also can run your container. And this is not the same thing as a virtual machine, although there are lots of similarities. Some of the differences that a virtual machine might be able to do better is that it will have better security features because a virtual machine actually has a guest operating system and it has a full operating system. And so it can secure your individual application a lot better than a container, which only has a couple of libraries and folders and stuff, and mainly relies on your host operating system instead. A virtual machine also can take snapshots of its current state and roll back to one of those if something becomes corrupted or there's an issue. Containers can't really do that to the same capacity. This could be useful if you have any data invalidation or anything like that. And also, a VM will be supported on most machines. You can run your VM on most operating systems. And it can also run your application on most operating systems. So your virtual machine itself could be a lot of different things. Most containers are based in some distribution of Linux, as we'll explore a little bit. But theoretically, if you wanted to run an application in Windows, you could do that with Windows VM. To my knowledge, there aren't any Windows containers. I don't think that exists. On the other hand, containers are also really useful because they can be started and stopped really quickly. So a virtual machine has an entire operating system built into it, and it has a lot of setup steps in order to get it running. And that takes a lot of time. A container, because it's built with just what the individual application needs, and it relies on the host operating system for everything else, it is much easier to actually get started and execute. They're also much lighter weight. Again, we don't have all the operating system stuff behind the scenes that has to be included, just the things that are important. And most tools related to containers are free. So Docker is free, Kubernetes is free. If you want to scale it up for an enterprise, at that point, there are different pricing plans and whatnot. But pretty much everything, any base image that you need for your container, and we'll talk about base images later, those are all available on a public Docker hub. So virtual machines are not always the case. You may have to purchase a virtual machine or certain tools related to it. Also, you can reuse code really easily. If you want to deploy stuff at multiple locations, you don't have to set up multiple virtual machines. You just share your image to different places and run it in a container. All right, two things that are really important is sort of understanding where Docker fits into this and also Kubernetes, and we'll do that next. So where Docker fits into this is Docker is a container runtime or container engine, and it's one of many. Other ones include containered or CRI-O. I'm sure there's a correct way to pronounce that. But Docker is the one that you'll hear about most often, and probably you will find most commonly in industry. Docker will let you build images from your application, and it provides ways of you customizing what needs to be in your image and in what format, which we'll explore a little bit. And it's usable either through a desktop GUI or through the command line as a command line interface. In either case, on your personal device, you will need to install Docker Desktop, which we'll do at some point, but if you're just waiting, this would be a good thing to do now. The Docker Desktop comes with the Docker daemon, which will run behind the scenes and will allow you to send Docker API requests like build my image, run my container. And so you need those in order to even use the CLI, even if you're not using the desktop GUI. And again, this comes with Docker Desktop, so you can just install that. And if you want to run the daemon so you can interact through command line, all you need to do is start up the desktop app, and it'll start up the daemon for you. All right, last slide before I pass it over. Kubernetes. Kubernetes is a bigger system that can manage your containers for you. And it's called a container orchestration system. It will move around containers to lots of different servers, scale up the amount of containers you have if you want some redundancy so that if one of them fails, there's something to take its place. Or if you have a lot of traffic to a particular application, you can distribute that traffic to multiple different containers running your app. And it can also just manage things. So if you want to change properties about your container, or you want to move it to a different location, you can do that. And it'll do a lot of this automatically for you, but also there's probably someone at your dream company that is just a Kubernetes admin. We had several where I worked over the summer. And this is super important for enterprises, which will have a crazy amount of apps that they need to manage. This is out of scope for what we're doing. We don't have that. We have exactly one, and we don't need a bunch of instances of it. But this is really cool. This is something that you'll probably touch more of if you end up using this in the industry. All right, passing it over to Carlos to get us started on the actual project.
Awesome. So today we're going to make a really simple Python REST API. If you want to, we're not going to go too in depth into what APIs are, different kinds and all of that. But if you are interested, we are going to have a workshop coming soon about different types of APIs, web APIs. So one of the first things that you guys should do is install the Google Cloud CLI. CLI stands for the command line interface. It's going to help us run command line commands that will help set everything up. And it also comes bundled with Python because it's a requirement. So it'll help if you don't have Python for this workshop. So let's just give like 2 minutes or something for now.
Honestly, just let us know when you're good.
Yeah.
More than anything. This will be a cut in video anyway.
Oh, okay.
I think so. It's not even too much either.
It's not that much. Like this isn't something that like takes a long time. I feel like I had issues getting Google Cloud.
By the way, you don't need to have a Google Cloud account just yet. We're just going to set up the CLI for now. Awesome. So let's start the actual Python API. So first things first, I'm just going to go to my desktop and create a new folder where we're going to host this. I'm just going to call it Docker demo. And you can pull up your favorite code editor. If you don't have one for some reason, I do suggest using vscode.dev. It's the same as VS Code, but just online. And it'll use your own files. So it's pretty nice when you are using a laptop where you don't have a code editor. So I'm just gonna open up the folder. Okay, give it access to everything. Cool. Okay, so let's begin. I'm gonna make the app. I'm just gonna call it app. It's gonna be Python file, obviously. And we're going to start by importing a few things. From right now, we're gonna import from Flask the actual Flask library and also the response. I'll go a little bit over what these do later. Okay, so first things first, we're going to initialize Flask, which is going to be our API facilitator. It's a really nice library to build really simple APIs. First things first, we're going to define a route using this annotation thing. Our first route, let's just call it /ping for now. And just to make sure that this works, we're just going to do a really simple API. So I'm going to define a function called ping, and all it does is return pong. So this is just so when we run it, we can test it out. And so now our API has, using Flask, it started, it has a route, and then we need to initialize it. So let's just say if name is equal to main. This just takes the name of the internal Python name that it's using, and when it's main, it's usually like this is the main app that's running. So Python does that for us in the background. So let's just app run. Let's just say the host is like 0.0.0.0. So it should be localhost. Let's put this in as a string. And we're going to define the port as 8080. So it's going to be open in port 8080. Okay, great. So we have a super simple API. We're going to make another route in a bit. That's going to be a little more complicated, but let's try this for now. So what I'm going to do is I'm going to pull up my favorite terminal, use whatever is best for you. And I'm just going to go to that folder. I'm going to go into my desktop. I call it Docker demo. Great. So if we run ls, we can see the files in here, app.py. Okay. So one of the first things we need to do is we need to install pip install Flask so that it can install the library for us. For me, I already have it installed, but it might take a little bit on a new computer. So let's assume everything's working great. Let's just run it and see what we get. So we do python app.py. As we can see, it starts a development server on our local host. So let's just take the middle address, for instance, and open it up. As you can see, it's going to say not found. This is because we don't have a route defined for just a regular slash, but we do have one defined for a ping. So if we do this, we know it worked. We have a route defined. It's just a nice pinging route. So let's make a more complicated API so that we can upload something of significance to Google Cloud. If you Control C, it'll quit, or whatever the command is based on your computer. Okay, awesome. So let's define another route. I'm just going to have this be the home route. So the homepage where everybody goes to, it'll be whatever we have in this function right here. So let's do something interesting. So here I'm gonna start a new variable called, ooh, this is not great. Gotta keep the same case for everything. Okay, so I'm gonna have an API URL. So our Python server is going to call an outside API. This API is going to be api.spacexdata.com/version5/launches. So here we define the URL, and we're going to import another library. This should be built into Python, which is the requests library. This is going to allow us to make a request to this URL and retrieve whatever data they are putting out there. So let's do that. I'm going to start a variable called SpaceX response. Here we're going to go to requests. We're going to make a GET request to this API URL. Awesome. And then we're going to turn this into a JSON, which is stands for JavaScript object notation. And it's the way that a lot of REST APIs and APIs in general transfer data. So let's take this SpaceX response. We're going to do .json, and it'll turn it into a JSON, something a lot more readable that we can use. So let's see what we have right now if we just return this. Let's start up the server again and see what happens. So I'm going to open it again, and it'll be in the home page. So as soon as we open it, we should get something, and we get something. We get a huge amount of data. So this is really ugly data. So let me just like a JSON formatter. You don't have to do this. I just want to show you a little bit of, if we format it nicely, what kind of data we're receiving. So I asked for the launches. So we're pretty much getting a big array of different launches. So let's just close up some. Let's look at this one. So here's what we want. We want to access the links field. Then we want to go to the Flickr field, and we want to go to original. This is going to be an array of links to images. So let me see if I can find some more down here. Wow, there's a lot that don't have images. Okay. Let's see if we can find a quick one. Okay, so even though this isn't an original image, this is an example of an image, or how we will get our data. It's going to be a link to an image, and it'll be some sort of image that we want to take. So let's go back to the app, and let's find a way to extract these images. So, oh, by the way, I'm just going to start an array right now that's called image links. So the purpose of this app is I want to take all the images I can get, and then I'm just going to pick a random one and show it to the user. So I'm going to make a for loop, say for every launch in this JSON response. Let's take the launch image, image links. I'm going to do this by, for every launch, we're going to go to the launch. We're going to access, like I said, the links field. We're going to access the Flickr field, and then we're going to access the original field, meaning this is going to be an array of links to images. And I'm only using original because I just decide I only want to use the original images. So first thing we check, is this array bigger than 0? So is there data in this array? If there is, let's go to our image links array and let's just append it with the links that we found. Actually, apologies, I'm not going to append it. I'm just going to do a plus equals. So in Python, when you have an array and you add another array, it just appends it both together. So that's what we're doing right now. So now let's do the process where we just select a random link. For this, we're going to import the random library, which is also built into Python. We're going to use the random library and say, make a random choice from all of the image links that we found. And now we're going to turn this into a response that we can return from our API. We do this by making another GET request to this random link that contains an image. And we're just going to return that now. We're going to use this response thing that we imported before. So we're going to return the response object. We're going to take this image response. We're going to extract the content field within it. And remember to do this, which is another, it's called MIME type. We're just letting Flask know what kind of data we're sending it. And I'm just going to say it's an image / JPEG. Okay, awesome. So we're going to run it right now, but if everything works, this is our entire API that we're going to build today. So let's see if we can run this again. Open localhost again. Awesome, it works. So we extracted, every time we refresh, it should collect everything again, pick a random image, and show it to us. So pretty cool. This is before launch. Awesome. So we have our app. Now it's Eli's turn to put this inside of a container, and we'll work on uploading it to Google Cloud after that.
All right, so on to the next thing, which is we're going to go into the Docker setup. One thing I want to do really quick while we're here in the same folder is I want to create a couple of new files. The first one we're going to create is a requirements.txt file. And here we are going to include all of the things that we want to bundle with our application that are useful. So on this particular instance of Python, we have installed a bunch of different packages here. I don't know how many of these are necessary. They might all be related. I honestly don't know. But what we should do is we should pip, in our terminal. So again, if we ls here, we should be in the same folder as everything else. We want to pip freeze and then a caret to the right, meaning put it into requirements.txt. And so what this will do, if we go ahead and refresh here, hopefully, this was desktop, Docker demo. Okay, so what this has done is this has put all of the pip things that we've installed into this file. And what this will let us do is when we create our Docker image, we can specify, take everything in here and install it in our Docker image as well, so that, again, all of our runtime requirements are available together. We need a couple of other things. One thing that we probably want here is a Docker file, and there's no file extension here. So make sure the case is correct and there's no file extension. What does this mean? Okay, so if we create our Docker file, this is where we're going to put in all of our instructions on how to build our image. We're going to leave this blank for now. We're also going to create a .docker ignore file. And again, this is case sensitive, put a dot in front. This should look like a git ignore if you've used one of those before. In our Docker ignore, when we want to build our image, we can specify what should you not use from the source directory. Things that we don't need to include in our image are the Docker file itself, because once we've already built the image and it's running, like we don't need it anymore. All we need is to provide instructions for the Docker daemon, so it doesn't need to be in our container. Similarly, Docker ignore can also be taken out. Let's say that I had a language like JavaScript, where maybe I was building a bunch of TypeScript files and compiling them into JavaScript. Well, eventually, once you do that, you won't need the, actually, this isn't a good example. This is a good example for another thing later. A better example would be in JavaScript, where if you install things, you do it locally to the project in a big folder called node modules. And you'll have just like a ton of things in there, way too many things, and you can't copy all of those into your image. Rather, what you want to do is you want to put all just the source files into the image and then install everything in there directly instead of copying everything over. So in that case, if this were a JavaScript project, we would want to put our node modules in here. But in this case, we don't need to do that because this is Python. Generally, if you have any build stages, you probably want to do them all inside your image as part of your Docker file. There'll be instructions to do that. We'll do some of them. But if you have things that you've already built outside that don't need to be included and will be rebuilt inside of your image, then you want to put them in here. Cool. So if you haven't already installed the Docker desktop, please make sure you do so. And then you'll need to open it so that the Docker daemon starts running. Once it eventually opens here, great, that'll be perfect. But until then, if you try to do Docker, just the command here, this will tell you like, is the Docker daemon run? And that means you have to open the Docker desktop. At this point, it's already open, the daemon is running. And so we have all these different commands here that we can use. And we've included in our presentation a cheat sheet that I think could be useful over here, which we put in a tiny URL. So you could bring this up in another tab if you want. But generally, we'll explain all the commands we're going to use here. There's way more things in there than you will really need for today, but most of these commands are useful. So tiny URL. Oh, that was the wrong one. You're right. You're right. GDSC Docker cheat sheet or CS. We'll keep this up in a side tab. So this is just a bunch of different containers that we can use, all prefixed with the Docker executable. We'll use some of these, not all of them, but you can keep it open for now. So let's go back into our Visual Studio, or wherever you're working, and let's start to create our Docker file. So again, a Docker file should have all of your instructions about how you want your image to build. And what we need to do first is we need to specify a base image. So our Docker builds will always have to start from a base, which just tells you what should be in the container or in the image just by default. What is your container going to be requiring to run? And we can go to the Docker hub to usually find these base images. Most of the base images you will ever need will be in here. We can go up to the Explore section here. And what we want is we want Python installed to a very small operating system that can execute it. And so if we look for Python in here, there is an official Docker image for Python, and it has lots and lots of different versions. So if we scroll down, there are versions for different types of Python. This is 3.12. There's as long as it goes back. There's lots of different tags on here. Typically, like the stuff that comes after is referenced as a tag. So some of these are slim, which means it's going to be a lot smaller than the full base image. And Alpine, which is the other thing that we are generally going to care about. Alpine is a distribution of Linux that we can use that's just a lot smaller. I don't actually think we're going to use Alpine for this, but what we are going to use is first we're going to go into our terminal and get, for whatever Python you have installed, get the version of it. So we have Python 3.10 here, which means that I want to grab a base image that has the same Python, or pretty close at least, in the hopes that some of our dependencies aren't going to be an issue. In this case, it really won't be an issue. We have just a couple of things. They're not going to be out of sync, right? But we want Python 3.10, and let's just get 3.10 initially. So what we're going to do is we're going to go into our Docker file, and we're going to say from Python 3.10. And this means get this specific image of Python. And this is going to be our base image here. So what we can do next is we can go ahead and set our workspace. So inside of our image, if we have a base image that like has a whole distribution of some operating system in there, then it's going to have all of the files that are required in there as well. So it's going to have lots of different places where there's libraries and yada, yada, yada. So what we would like to do is put all of our stuff in a subfolder that's just for our application. So that's what we're going to do with our, sorry, not workspace. We want workdir, and that should highlight blue. And so this means that all of the future commands that we're going to put into this Docker file will be executed from this specific location. So one thing that we can do is we can copy, which says take files from somewhere. In this case, if we don't specify where, it's going to take it from our local file system where we put all of our source. And we're going to take requirements.txt from there, which is where all of our Python libraries versions were specified. And the second part is the destination. And so the destination is going to be by default, whatever base image you're currently working from. You can have multiple base images. One thing that you can do is you can have a base image and then put a bunch of stuff in there, build a bunch of things. So in this case, you could like compile TypeScript into JavaScript, and then specify another image down the line and take everything from your first image, but only the things that you built that are important, and put them into the new image. And that way you have just a tiny amount of things. This is called a multi-stage build. We're not going to do that here. In this case, we're just going to stick to one. So our destination is going to be this Python 3.10. And we are going to copy into just our current location, which is that work directory /app. So this is a local or a local, rather than an absolute address, this is like a relative address. So this means in our current location, put it all in there. And now we can run commands in there. And so we have Python installed because this is a Python image. And so we can run pip install. And one of the cool things about requirements is that if we want to just install everything on that requirements file, we can do /r requirements.txt. And that will put everything on there with the exact same versions and install that, which is great because we want everything to be consistent across all of our environments. Now that we've done this, we can copy everything else from our local directory into our base image. So we can do that with a period, which just means everything. And this will take everything else. This will take our app.py. We could also put our, no, we can't put our requirements.txt in there, but it will take our app.py and put it in there. And once we've done that, we can now go ahead and run our server. So what we did previously was we did Python and then app.py, which is what we called it. When you're using a CMD, which means this is how we're going to execute our container, there's multiple ways of doing this, but the way that it's recommended is by splitting up all of the different pieces like this. Cool. So we did this. Let's see if it worked. So we can Docker build, and let's give it a tag so we can reference it easier. So we'll call this API image, and then a period to just say build everything that's in here. And again, we're in the same Docker demo repository directory. And this will go ahead and do a bunch of stuff here. Hopefully you won't get any errors. This will take longer the first couple times you do it. If you build it multiple times over, usually it'll cache some of the things from the previous builds. And so it won't spend as long. You'll also notice that there will be steps enumerated for you. So this is step 1 out of 5, which is our from. So it's pulling in the base image, which is what's taking so long. All of these really long SHA things here are basically identifiers for specific images, which can be helpful for if you need to differentiate between multiple builds of an image or anything. Okay, so now it's going into our work directory, it's copying in the requirements, installing all of them. Telling us our pip is out of date. We don't care about that. Cool. So that went ahead and worked. We can now check that it works by doing docker image ls, which says get all of my images. And the one that we just built is in here. So we tagged it as API image, which is now what it's called. If you don't tag it, it's just going to come up with some garbage name for you, or it's just going to be a sequence of characters. 8 seconds ago, and this is almost a gigabyte in size, which is kind of big. It's not great. Let's try if we do Python slim instead. So if we change this to slim, and let's go ahead and build this again, but let's call this API image slim instead. And again, you'll notice that a lot of this goes a lot faster. Some of it gets cached, and let's do docker image ls one more time. This one is only 150 megabytes, which is a lot smaller. When you get to, like, for our purposes, it probably won't matter if your thing is a gigabyte or 100 megabytes, but in general, smaller is better. And so finding ways to minimize your Docker image and have only the things you need is really important. And also coming up with the instructions to actually get the right image build and make it work is also really hard. And so it always takes some practice to finally get a build or a Docker file that works. And once you do, you can rely on it for a while. So it's a bit of a puzzle. Let's go ahead and run it just to make sure this works. We're going to use the docker run command. We need to specify the -d flag, which means detach it from this terminal, let the terminal continue doing things and run it in the background. We need to expose some ports. So this is running on 8080. In a container, it will not be able to be accessed unless we expose the same ports. So we're going to expose on our local machine 8080 and in the container 8080. And let's specify a name for this container so we can reference it. So this is API container. And then let's specify the image we want, which is image slim. And let's go ahead and run it. We can do docker ps, which gets all of our running containers. So we can see that our API image slim is running as of 4 seconds. Let's go ahead and see if that works. So we should now be able to go to 0.0.0.0, 8080, and we should, oop, maybe not. Yeah, we can try it. Oop. Oop. All right. And it's still running, which is great. Let me just make sure it works with the base route 2. My guess is it just hadn't quite finished starting up yet. Cool. So it still works. Because we opened the port, it can be accessible from our main machine. And this is really important for when it ends up running on a cloud platform somewhere. All right, there's lots and lots of fun stuff that we could do here. I don't want to hold up anymore. I wanted to get as much done as we can in the next 7 minutes or so. So I'll skip over some of that. And I will pass it back off to Carlos to finish this out with the Google Cloud stuff.
Awesome. Thank you. Awesome. Okay, so now that we have a local container running this, let's put it up in Google Cloud. So first let me go into here. I'm gonna go to the running containers, not running anymore, so that's great. Let me actually delete this. That was from before. Awesome. So the first thing we want to do is we want to go to Google Cloud. So you can look up Google Cloud Platform. And because I already have a Google Cloud account, I can go straight into the console. If you're in another account, for instance, doesn't have it, you can go through the process where you can start for free. Now, one thing that sadly we couldn't really get out of is Google Cloud does require, if you're an individual, it does require a credit card or debit card. This is just, according to them, it's to make sure that you're human and so they don't get spammed with accounts. Feel free to look at this like in your own time and look at the recording of this and do all of this in your own time if you'd like. And just feel free to follow along if you wouldn't like to put your card information, obviously. I would say they do give 300 credits for free, and you won't be charged after the free trial ends, etc. And what we're doing here today won't even come close to charging you like even a cent, because it's really, really small and it's not anything huge. So once you have your Google Cloud account, you can go to your console, and here I already have a project, but let's create a new one. You go through the process of creating a new project. I'm going to call it Docker SpaceX API demo. I'm going to create it. So while it's in that process, let's wait a couple seconds. So the point of Google Cloud is it'll host this project for us so that we can share it with the world and with the internet, and you get some experience into running containers on the cloud. So I just selected this project, so I'm in my whole new project. First thing I want to do is I want to type in container in the search bar, and we're going to go over to the container registry. Here's where we have to register our local container. Let's give this a little bit to, yeah. So on your first time, you click enable. It's going to enable this API or the registry API so that we can use it. Okay, so while this is going, one of the other things we can do is we can go to our terminal and, well, this is done, but as you can see, it's empty. We have no container in here. So let's go to our terminal, and currently, if we go to Docker desktop, or even if we just type Docker images, we can see the two images that we just created. And we're going to be working with the slim version just because it's smaller, it's faster. Okay, so the way that you take your Docker image and then you push it to the cloud is the following. So this repository name right here needs to match with a URL repository where you can upload this to the cloud. So the first thing that we need to do is Docker tag. So this is going to change the entire tag name, and we want to change it to, for instance, gcr.io, which stands for Google Container Registry. This is a URL owned by Google, and it's specifically for this registry that we want to work on. So the next input is going to be your project name. So if we go over to your project, check that your project, that you're in your project, and here you'll have the ID, so you can just take it from here. So paste in your project name, put another slash, and here we can put the same tag we had before. So API image slim, You can put a colon to define a specific version. So let's just call this the latest version. That's how you spell latest. Okay, awesome. So requires 2 arguments. Let's see, I might have missed something. Okay, so let me just go back really quickly. So this requires 2 arguments. It requires the existing tag name so that it knows which one you want to change. So we want to change API image slim to this URL. Okay, so that should work. If we check our Docker images again, we should have one that has the URL that we want. Awesome, so that's great. And now if we go to Docker desktop, we should also see it in here. So far, obviously, if we can refresh here, there's nothing here yet. So everything's still local. And the way that we're gonna put this in Google Cloud is we can do Docker push, and we'll put the repository name of what we just created. So I'm just gonna copy and paste it. So we're gonna take this image, its name, push it, make sure it's got the latest tag after the colon, and oh, okay. So one quick thing, it is pushing for me because I already have Google Cloud CLI set up. If you don't have it set up, it should give you an error. So just follow these steps. Just do Google Cloud login. So because I'm already signed in, it's just gonna bring me here, but you can do that, sign into your Google Cloud account that you created, allow it access, and now you're authenticated with a CLI. And then you're gonna need to do one more step before you can push like I did, which is going to be Google Cloud auth configure Docker -Docker. Okay, so this should configure the credentials of Docker so that it can access your Google Cloud. So after that's done, you can go ahead and push it like I just did it before. Awesome. So after pushing it, we can go to Google Cloud, refresh, and here we have it. It's also the visibility is private, so it means it's a private image that we have here. Great. So now that it's in here, we can actually host it in the cloud. So right now we only registered into the Google Cloud. We haven't hosted it anyway. So the way that we can run and host this is using Google Cloud Cloud Run. So if we go to Cloud Run, it's going to give us a couple of options. We can do services or jobs. We're going to actually create a service. Here we can select a container. We can go over to our container registry where we just created this container. Select the one with the latest tag. It's the one that we just uploaded. It'll autofill service name, region. There's lots of options here. One of the things I suggest, because we want to minimize the amount of, because we're running under the free tier, we want to minimize the amount of usage. I would just do the maximum number of instances to 1. So if for some reason you get like a huge traffic spike, it won't damage anything. It's going to be 1 single container. We can also make it an internal tool, but for now we want to allow anyone access. And we're going to allow unauthenticated invocations. So it's going to be public. And then depending on the port that you opened, for us, it's matching, but you'd come here and change it to whatever port. Awesome. So let's create this. And it should be pretty quick if everything that we did is good. So right now it's taking that container, it's setting it up in Google Cloud Run, it's starting it up and making sure that it's going to give us a URL. So if anybody accesses that URL, it's going to start up an instance of that container and it's going to run it for us. And if you have your own custom URL, you can also hook it up to it and it'll go to your own custom URL.
Button on my phone that can just instantly start playing Jeopardy.
So also, as Eli mentioned before, there's a service called Kubernetes, which was actually started at Google, and it's a container orchestration service, and they actually host it for you. So if you're interested in containers, or if this seemed like a really like easy to set up example, I would definitely look into it, and you can start learning more about it. Okay, so our URL is set up, and it gave us its own custom URL. And if we go to it, boom, our API is working. Awesome. So you can share this URL with anyone that you want, and your container will run, or you can call APIs to it, anything like that. Awesome. So, okay, so that's it for the Google Cloud demo. Please feel free to come back and take a look at the recording and everything. If there's any feedback, please let us know. We read everything and we make sure that we can incorporate the latest feedback into our workshops. Thank you so much. Hey, sorry, I didn't see the question before, but basically, yeah, you can deploy almost any kind of project using Google Cloud. You just need to use whatever tools they give you. So if you can put it in a container and upload it to Google Cloud,